Hey everyone, welcome back. You know how we always talk about AI being this great leap forward in efficiency? Well, today's deep dive is going to make us think twice about that.
It's true. We often assume that newer, faster technology will equal less waste, right?
Exactly. But what if I told you there's this thing called the Jevons Paradox that says sometimes becoming more efficient with resources, well, it can actually lead to us using more of them overall.
Yeah, it's a bit of a head scratcher, isn't it?
It really is. So you sent over some fascinating stuff about this one article on the Jevons Paradox itself, and then another one that connects it to, you guessed it, AI.
Right, because that's where things get really interesting.
Absolutely. But before we go full AI brain meld, let's back up a bit for our listeners who might be new to this whole paradox thing. What's the gist?
Okay, so imagine it's 18th century England, okay? Coal is powering just about everything.
Gotcha. Coal is king.
Right, and then along comes this guy, James Watt, who invents a much more efficient steam engine.
Makes sense. Innovation. So less coal, everyone wins.
You'd think so, right? But here's the thing, it didn't quite work out that way.
It didn't. Wait, they figured out how to use coal better and somehow ended up using more of it. How's that even possible?
Because Watt's engine didn't just use coal more efficiently, it actually made it cheaper to use. So suddenly, steam power was more affordable. Everyone and their brother wanted in on it. Factories, transportation, you name it. Demand went through the roof.
So even though each individual machine was using coal more efficiently?
The sheer number of machines and the overall demand just skyrocketed.
Wow, okay. It's like when you find a killer deal at the store,
Yeah.
right? You might buy more just because it's such a bargain, even if you didn't need it before.
Exactly. And that right there is the heart of the Jevons paradox. That change in demand is key.
Okay, so now let's bring this whole thing into the 21st century.
Yeah.
Our coal today is more like computational power.
Exactly. It's the fuel driving the AI engine.
So as AI gets more efficient,
Yeah.
you're saying we might just end up using a lot more computational power overall.
That's the question, isn't it? It's like, imagine a future where AI is as ubiquitous as smartphones are now.
Oh, I can see where this is going.
Everyone from businesses to researchers has access to this incredibly cheap and powerful AI. What happens?
Well, more users mean more demand. More demand means more energy use. Even if each AI process is somehow cleaner, the sheer volume of it all, that's got to have an impact.
You're getting it. And here's another layer. It's not just about more people using the same AI tools. We're talking about entirely new AI applications emerging, stuff we haven't even thought of yet.
Each needing their own massive chunk of computational power.
Precisely.
It's like, remember back when smartphones first came out, suddenly there was an app for everything?
Oh, yeah.
And battery life.
Yeah.
Forget about it. Now, magnify that to a global scale with AI, suddenly this Jevons Paradox thing is feeling a little less theoretical and a little more real. Okay, so it sounds like this AI-powered energy surge could be a real thing. But the article you sent, it did say this Jevons Paradox thing isn't a sure thing, right? Like maybe efficiency wins out in the end?
That's right. It's not inevitable. The key is how big that demand spike is. Because of the efficiency gains, there's actually a term for it, the rebound effect.
The rebound effect. Okay,
Yeah.
so how does that work?
So think of it like, let's say you go out and buy a fuel-efficient car.
Right, better gas mileage.
You save some money on gas, feel pretty good about that.
Yeah, saving money.
But then maybe you start driving more because, hey, it's cheaper, right?
Ooh, I see where you're going with this. So if everyone's out there driving way more, the efficient car doesn't really solve the problem.
Exactly. If everyone ends up using a lot more, even with the efficiency gains, that's like 100% rebound effect. And that's when we really see the Jevons paradox in action.
And with something as complex as AI, being adopted in every industry, how can we even predict that rebound effect? Seems impossible.
It's really hard to say for sure. The research you sent, it didn't even try to give a definite number. It depends on so many different things. How quickly the AI tech develops, how widely it's used, even government policies around energy and tech.
So basically, lots of uncertainty. But let's say, just for the sake of argument, this massive increase in computing does happen. Are we just doomed to repeat the mistakes of the past, like with the coal, just with better tech?
Not necessarily. I mean, the Jevons paradox isn't about being powerless. It's about understanding the possible consequences so we can plan for them.
Okay, it makes sense.
It's not like we're just along for the ride. We can't just focus on making AI more efficient and expect everything to be fine. We got to be smarter than that.
So it's less about, stopping AI development altogether and more about being careful steering it in a way that doesn't destroy the planet in the process.
Exactly. And there are some really interesting solutions out there. The articles you shared, they highlighted a few really promising ways to handle this potential problem.
Okay, so what do we talk about here? What kind of solutions?
Well, one thing that came up a few times was using green taxes on computing resources.
Okay, green taxes. So like,
Basically, taxing the energy that data centers and other computing infrastructure use.
so even if the AI itself is making computing cheaper, we add a cost back in that reflects the environmental cost, right?
Yep. It's a way to make those environmental costs more real and encourage people to use resources more carefully.
Interesting.
And it gets even more interesting. Another idea is using cap and trade systems.
Wait, cap and trade, but for computers? How would that even work?
It's a little complicated, but basically there would be some kind of central authority that sets a limit on the total amount of computing resources that can be used.
Okay, a total limit. Got it.
And then companies and organizations would get allowances, basically permission to use a certain amount.
And then they could trade these allowances, right?
Yeah.
Like if a company's doing super efficient AI work, they would have extra, and if someone needs more, they could buy it.
That's the idea. It encourages everyone to reduce how much computing power they're using and invest in those efficiency improvements we were talking about.
So the companies that could do more with less, they actually benefit. That's a cool way to think about it.
Right. It could drive a whole new wave of innovation.
Okay, so we've got these green taxes to, make people think twice about energy use, and then this cap and trade system for computers to really push efficiency. What else is out there? Okay, got to be honest, some of those solutions sound kind of intense, like green taxes, cap and trade for computers. That's not exactly going to be easy to implement.
Yeah, you're not wrong. It's complicated stuff. We're talking about big challenges that need a lot of planning and, countries working together to make it happen. But that's exactly why it's so important to understand this whole Jevons Paradox thing. The sooner we start thinking about it, the better prepared we'll be.
Makes sense. Like, if we can get ahead of this now, while AI is still kind of in its early stages, we have a better shot at avoiding some major problems down the road, right?
Exactly. We have this opportunity to steer AI in a direction that doesn't, completely wreck the environment.
And it's not about being anti-technology or anything like that.
No, not at all.
It's about being smart and proactive.
Right.
And that, my friends, is where you come in. This isn't just some abstract conversation we're having. This stuff has real-world implications.
It really does. It comes down to awareness. It's so easy to get caught up in all the hype around AI, all the promises of, a more efficient and prosperous future.
Sure, who doesn't love a little bit of progress?
But we can't lose sight of the bigger picture. Just because we're making advancements in one area, like AI, it shouldn't come at the cost of the planet.
Right. We can't expect tech to magically solve everything without any consequences. So we need people like you out there, informed, engaged, and asking the tough questions. Help steer things in the right direction.
That's it. And that brings us to our final thought for you to chew on. We've talked about the Jevons Paradox and all its potential pitfalls, but the real challenge, the question we need to keep asking ourselves is this. How can we design our economies, our technologies to encourage not just efficiency, but real, lasting sustainability?
Big questions, no easy answers. But hey, that's what deep dives are all about, getting you thinking, giving you some new perspectives, and maybe a little food for thought to take with you.
Absolutely.
Well, that wraps up our exploration for today. We hope this got you thinking a bit differently about AI, efficiency, and what it all means for the future. Until next time, stay curious, keep asking those tough questions, and keep diving deep.